Good afternoon. Good afternoon, everyone. We were studying fiber optic communication or optical fiber communication. For that, we have started with our first previous 2-3 classes. In that, we have seen what is optical fiber communication, and then we have seen the types of what are the modes of optical fiber communication. And in this class, we are going to see what is the construction and what are the parameters or of optical fiber cable. Okay, so we will have this construction picture that whenever you see a optical fiber, you cut that from the cross sectional area, you will see these many parts of the optical fiber cable. So this is the first thing from where we are going to transmit our light data. This is called as core. See how many coverings it have. Then this is also a glass part. This is called as cladding, and this is the coating. Okay, the light should not come out from this cable, or it should not be or anything should not penetrate in this cable. That's why it has so many security coverings. So they are called as cladding, coating, and then this is strengthening fibers. ओके आप लोग कभी इसका टेलीफोन का वायर काट के देखना, तो आपको ये वाला जो कंस्ट्रक्शन है, दिस टाइप ऑफ कंस्ट्रक्शन यू विल सी. So that is nothing but a optical fiber cable. Okay, so these are the strengthening fibers, a bunch of fiber. It is rounded, the coating. After the coating, it is fixed over there, and then at the end you have cable jacket. जैसे आपको एक normal wire दिखता है ना, वैसे नहीं दिखेगा ये, आपको थोड़ा सा जाड़ा वायर दिखेगा, बट इसके अंदर इतने सारी चीजें हैं. यू हैव सो मेनी कोटिंग्स ओवर देयर, एंड द फाइनल वन व्हाट यू सी फ्रॉम आउटसाइड, दैट इज अ प्लास्टिक जैकेट. दिस इज कॉल्ड एज केबल जैकेट. So exactly this is the construction of optical fiber cable. From this core, we are going to enter our data. We are going to transmit the data in the form of light. Okay, so what are the parts of optical fiber cable? Here we have given in a table that these are the components, these are the functions, and these are the materials used to design these components. So what are the components? First we have a buffer. It protects fiber from outside, and this is made of nylon or plastic. Then there is a central member which is which have the function of facilitating stranding, temperature stability, and anti-bulking. Okay, and this is made of steel or fiberglass. Then you have cable jacket, the outer covering what you see, that is called as a cable jacket. It contain and protect cable core. Then it is made up of PVC or Teflon. This is filling compound. Cable filling compound. This prevent moisture insertion, or what is the material? Water blocking compound. Okay, because whatever optical fibers you have for your telephony system, you have to make them, or you have to make them go from underneath, that is be under the soil. So there already you will be having moisture, you will be having water, you will be having sand. So you have to protect the cables from all these things. So what we have a fiber filling compound also, that is called as water blocking compound. Then we have strength member. This gives tensile strength to the optical fiber cable, and it is made of either steel or armored yarn. Then what is the buffer? There are two types of buffer. One is loose buffer and the other one is tight buffer. Loose buffer is used for outdoor application, and the tight buffer, it is used for indoor applications. And then whatever optical fiber you have some colors. जैसे you see in the copper cable also you have mainly three colors in that. Which are the three colors? One is you have red, blue or black. Red or black is main, and you have blue also, sometimes you have yellow also. So there are some codes of optical fibers also. If you have six wire cable, so it has the color as first is blue, orange, green, brown, slaty color, and then white color. These are six colored optical fiber. And if you have a 12 colored optical fiber, you have blue, orange, green, brown, slate, white, and then you have red, black, yellow, violet, pink, and glass, or that is a natural color. You can have you can call it colorless also. Then you have optical fiber components. Components can be like pigtail, you have patch cord or FDC, and connectors. So connector requirement, first of all, whenever you are going to have optical fiber communication, I am repeatedly saying that connectors are very important in that. Okay, if you have proper connectors, because you are sending what data, you are sending nothing but light. So the light data you have to save it from so many parameters. Okay, there can be a breaking, there can be a bending, so all these things will add losses to your optical fiber cables. So we have to avoid that. Okay, so we have to make the connector requirement properly. You have to make a proper connector so that the losses should not be there. So the attenuation in optical fiber connection, it should not be less than 1 dB. ओके, जो हम कनेक्टर डिजाइनिंग कर रहे हैं उसके लिए ये सारे रिक्वायरमेंट्स है कि उसका जो लॉस है it should not be less than 1 dB. Then the connector must provide persistent performance on each remating means consistent performance on each remating नहीं है, वो remating है. Remating means connector प्लस फर्स्ट कनेक्टर है, सेकंड कनेक्टर है, थर्ड कनेक्टर है. ठीक है, तो आपको एक बार निकाल के दूसरी बार आपने यदि प्लेस किया, सो इट शुड गिव कंसिस्टेंट परफॉर्मेंस. Okay, the connector must provide protection to fiber so that it does not break while being handled. कनेक्टर का ये भी एक एप्लीकेशन है. इट शुड प्रोटेक्ट योर फाइबर from breaking while you are handling it, while you are wounding it, and while you are making the connections of optical fiber cables. Connector must be cost effective. This is the most required component, that the connector should not be very costly. Then we'll have in the next slide. This is optical fiber measuring instruments. Okay, ऑप्टिकल फाइबर यू हैव डिजाइन, आपने डिजाइन कर लिया है ऑप्टिकल फाइबर, बट इफ यू वांट टू सजेस्ट इट फॉर अ पर्टिकुलर एप्लीकेशन, first of all you have to perform some sort of tests on that optical fiber cable. So what are those types of tests is cable loss, you have to think of splice loss. These are all measuring instruments. Okay, here you will have an instrument which will measure cable losses. Then you will have a instrument which will measure splice losses. Then you have connector losses. Then you have fiber length. Okay, fiber length, if you want to measure, you also have one measuring instrument for this. Then continuity of fiber, just say like you measure continuity on your copper cable, you can measure continuity of optical fiber also by an instrument. Then you have fault localization, and then break fault. Okay, like when you have cables, you have optical cables, but you have to use it for a longer time. It should have a longer life, because हर बार हम लोग खोद के वो ऑप्टिकल फाइबर चेंज नहीं करने वाले हैं, ठीक है। एक बार वो आपने डाल दिया under the soil, if you have putted that wire cable, it should have years, it should have a life of years. Okay, that's why all these measurements should be done before putting the optical fiber in use. These are the main instruments required. Calibrate what are these instruments? These are the instruments required whenever you are using a optical fiber cable. Calibrated light source, you know, you is required for this. Then optical power meter you required for this. Then optical attenuator you also require. Then optical time domain reflectometer. Okay, this instrument is also required whenever you are using optical fiber cables. Then what is a calibrated light source? You all know what is calibration. Whenever we have to measure some parameters, we have to calibrate that instrument. So whatever light source we are using, we have to first calibrate it. Okay, so how we are going to calibrate that light source? We are going to calibrate in terms of power and in terms of wavelength. Okay, then we have calibrated power sources. Power sources. Okay, optical, they are calibrated in terms of optical power. Okay, and the measurement devices, or whatever you have, if you have a calibrated light source and if you have a calibrated power source, you must have very much accuracy on that. Your detector should be very accurate. Okay, so accuracy is one of the factor which should be there whenever you are designing any instrument for either detection or either for correction. Then these are power attenuators. What are power attenuators? There are two types of power attenuator. First is fixed attenuators, and the second one is variable attenuators. Now what are the applications of power attenuators? These stimulate the regenerator loss of the FDF to provide local loop back for testing and to measure the bit error rate by varying the optical signal at the receiver input. हमें जो application है, ऊपर के दो application, the upper two applications are of not general use. What for what we are going to use this power attenuator is for varying the optical signal at the receiver input. This is for this purpose, we are going to use power attenuators. Now, what is OTDR or other? Uh, what are the other measurements of optical fiber? You must measure fiber loss, you must have splice loss, then there is connector loss, fiber length, continuity of fiber, and fault localization. This we have seen earlier also. So these are all with optical fiber cable parameters. Okay, so in this presentation, for today's presentation, what we have seen, we will just have an overview. We have seen what are optical fiber communication. Okay, in that we have started with optical fiber communication. In that we have seen so many parameters of optical fiber. We have seen the modes of two types of modes also there, that is single mode and multi-mode optical fibers. In multi-mode optical fibers, we have seen step index and graded index optical fiber. And in today's presentation, or in this presentation, basically we have seen what are the construction, what is the construction and what are the parameters related to optical fiber cables, specially for cable only. Okay, so what is this? This is the cable designing. I have described you this in details. Then these are the parts of optical fiber cables with their functions and with the materials used for the designing. Then this is the buffer. Buffer is a main part which we use in optical fiber cable. There are two types of buffer. First is loose buffer and the second one is tight buffer. So we use loose buffer in outdoor applications, and in indoor applications we use tight buffers. Then these are the 6 color codes of optical fiber cable. If you have 6 wire cable of optical fiber, you have these much of colors from blue to white. And if you have 12 colored optical fiber cable, so you have these colors from blue to natural, or say no color, that is glass. Then you have some components of this. Then connector requirements are there. You have some measuring instruments. All these instruments are for optical fiber testing. Remember, in this lecture particularly, we are not talking of the communication setup, optical fiber communication setup we are not talking. We are only concerned about optical fiber cable. We are only talking about the cable itself. How the cable look like, how the construction is there, and what are the parameters related to the cable. We are not seeing the transmitter of optical fiber communication. Okay, that is the other part. Only the center part we are seeing. Okay, so these are some instruments required for designing of the optical fiber cable. That is calibrated light source, optical power meter, optical attenuator, and optical time domain reflectometer. Okay, then what is calibrated light source? This is described in that. Then power attenuator also we have seen. Then what is OTDR is used for measuring? This measures fiber losses, splice losses, connector losses, fiber length, continuity of fiber, and fault localization. So this is all for today's presentation. Okay, if you have any queries or if you have any questions, you can post, you can mail me or you can WhatsApp me on this, on the given numbers. So this is all for optical cable construction and components. So we will end with this class. So we will stop here. Thank you very much to you all for listening the class.